Hi everyone, it's Nono here, and I want to welcome you to my live stream on creative AI and coding. I'm Nono Martínez Alonso, for those of you who don't know me, and I also host the Getting Simple podcast. I will remind you if you're new to the channel or if you're watching this offline, that I will post timestamps for this video as soon as we finish, and you'll be able to jump or skip to the interesting parts. And I'll also remind you that you can subscribe and click on the bell if you want to get notified when I go live next or when I upload new videos. Without further ado, I'll tell you we look at different things that have to do with creative coding and AI in this channel. And that today we're going to take a look at Google's Gemma's model, and we're gonna do some other things. Again, take a look at the timestamps. You can see what ended up happening in this video. All right, and I also will invite you to join the Discord community. We have an invite at nono.ma/discord, and last week we took a look at how to deploy applications to Vercel. We did so by creating an application with Yarn and Vite that basically had a scaffolding of a TypeScript and React application. As you can see, you have the chapters there. We also took a look at some other stuff. And as I said, what are we going to do today? Today, I'm going to first talk a bit about the Elgato Prompter. So this is a new device I'm using today, so I can look at the camera and see my slides at the same time that I'm presenting, or put some other content there that I want to comment on. And we'll look at the Hugging Face CLI and also at Google Gemmas. We're gonna try to see if we can run it, but I'm not too sure what we're gonna be able to do with that today. All right. This is Elgato Prompter. This is a teleprompter that for the price that they've put on this device is really affordable for what it gives you, because it has not only a mirror that mirrors whatever you put below, it has an LCD display below it that is what you can see right in here. That actually allows you, with an application they have this called Display Link, allows you to use that display connected via USB-C to your computer as an extended display. That means that it's a second or a third display in my case, where I can drag and drop windows. For example, right now I have keynotes, presenter notes, but I can also flip to the YouTube chat. Feel free to say hi and let us know where you're connecting from if you join us live today. And yeah, so basically this device that I think is around 300 euros is pretty neat. It's working pretty well. I have it set up with my Sony ZV-E10 and the Sigma 1.4 11 or 16 millimeter lens. I have forgotten right now. It might be 16 millimeter lens, which with the crop factor of this camera ends up being around 24 millimeters. But it works out. It's if I look here, the teleprompter screen is right here, and I can see this shield here. So this is the screen, and my monitor is right at this edge, right? So this would be the part where the monitor goes, and that allows the wide lens to not show anything of the monitor or the prompter itself. So yeah, I really recommend it. I mean, I haven't used it too much, but even for recording face-to-face meetings or things like that, it's pretty good. So really happy to have this, and let's see if this makes some of the content better, easier to create, and more engaging as well for people like you that are watching. Okay, now I'm going to be talking about Google Gemma. So I'm gonna do an intro as if this was a tutorial in case I share later, or for people who just click on the timestamp and have that intro there. So let's get into it and start going. Hi everyone, it's Nono here, and this is a hands-on overview of Google's Gemma. So this is a model that Google has just released. Is the equivalent to Llama in Meta or Facebook AI. This is Google is releasing open models, large language models or LLMs, which we can download directly from Hugging Face with the Hugging Face CLI or from the Hugging Face web interface. And they've released 2 and 7 billion parameter networks that we can use directly on our machine. Uh, Google Gemma open models means that they have trained these networks, they have benchmarks, and you can see how well they perform in certain tasks compared to other models like Llama or Mistral. And yeah, it's family of lightweight, state-of-the-art open models built from the same research and technology used to create the Gemini models. I have to say, I haven't used them yet, but I have downloaded them to my machine. It's pretty easy, and you can do the same. We're gonna see how to do that right now. The first thing that I did is I went to Hugging Face. I searched for Google/Gemma, and then you get a series of models there. So the two models are 2 and 7 billion parameters, but there's two different varieties of each because each of them has the model itself and the IT, which is the instruction based model. And yeah, I had to sign or like accept the terms in Kaggle, and that gave me access. It was called a gated model that gave me access in Hugging Face. So by logging into the console and prompting to download, I could download the model. All right, so let's now code and let's take a look at the hands-on view of how to actually download those models in Mac. And note that this might work on Linux and Windows with your machine as well. Okay, so here, let me take a look. All right, let me take a 1 second. Let me take a look here and see something on the stream. All right, seems like everything's working. As you can see in here, I already have these models. So these are Gemma. I think I downloaded actually this one and this one. There is a way in which I don't think I finished downloading this one. There is a way in which you can download these models with symlinks. That means that the models are not downloaded to this folder. They're just symlinked from the cache folder to which what is the name? The Hugging Face CLI downloads this thing. So I can actually go here to cache and then go to Hugging Face, go to that directory, and we can actually see some of the temp files and some of the models that I've downloaded before. So for example, here we have files for these models that we were talking about. You can directly delete everything here, or I could delete some things that seem like never really downloaded properly and get that done. So if we go back, these are the models. This GGUF format is actually a dump here of 10 megabytes. So that's for the 2 billion parameter model. And for the 7 billion parameter model, we actually have 34 gigs, and there's some other model files in there. So let's see how I got to download these things with the CLI and open here a terminal. and comment a bit on how we might be able to use these things. I actually already had the code from the live stream I did on Llama, and I think I might not have that on my machine anymore. So if you go to the live file with LLMs on Apple Silicon with Llama C++, I'm pretty sure that this covers how to do this, and maybe we can even revisit that and take a look to make sure that we know how to do that. But yeah, let me try to refresh my mind and do that later. Okay, let's download Google Gemma with Hugging Face CLI. On Mac, I mean, you can first go and look for the CLI, look for the documentation. So here I looked at, basically in here you have this use the CLI guide, and it will tell you how to do these things. And then on the right, you actually have instructions on how to do things with that CLI. One note is that I actually ended up installing with Homebrew, so I didn't really install it with the method on the website. And on Mac that worked pretty well. So actually, I have some notes here. Install. Yeah. So let me actually take a look here. Brew sh. Yeah. So this page here that I'll put on the chat, maybe let's put it on the chat. This is, what is this? This is Hugging Face CLI Brew sh link. All right, and I'll put that there. Great. Okay, so we got this. So all I did, like we could actually do an uninstall. So I could do here brew uninstall Hugging Face CLI, for example. This is actually going to revert the process, and we will just have to set here. Okay, so let me actually put this in here and this here. Okay, let's install the Hugging Face CLI with Homebrew. So here I'm gonna go to the homepage. So it's the formula is basically brew install Hugging Face CLI. You can see some information here, but all you have to do in the end is brew install Hugging Face CLI, right? So that's what we need to do in order to get the CLI installed in our machine. If nothing else has to happen here, that works, and then we'll be able to do here Hugging Face CLI. I'm not sure if version works, maybe not, but we'll just do help. And yeah, so that seems like it works. And now we can do things like login, logout, and other things. All right, so let's now see how to log in with a token to the Hugging Face CLI. You actually have to go to huggingface.com/settings/tokens, which is this page here. And I'm not going to show the token here, but I can copy it. This is my account, and this is token I created today. So you have to go expressly to this URL, huggingface.com/settings/tokens, and then you just have to go back to your terminal and do Hugging Face CLI Login, and it will prompt you for a token, which I've just pasted, and then I will just say login successful. Okay, so now we're gonna see how to download a model from Hugging Face. We were talking about Google's Gemma, so we can, as I did before, I can go here and directly search for Google/Gemma, and then we'll see. Well, if you actually just do that, so Google/Gemma, you actually get the results here, and we can go, for example, for the Gemma 2 billion IT, and then we can read on the information that they've put here for us, and how to run things and how to do things and blah, blah, blah. So what I'm going to do is I'm going to go to files and versions so you can see the things that they've put here so we can download. And you could download one specifically, or you could download the whole repository, right? Let's see how to do both. I'm gonna go to the desktop. We have a folder for today's stream, which has already downloaded 2 models, but I'm gonna do here a test folder, which we're going to also enter. So we'll open this folder and I'm gonna put it here for you. I think there, yes. And now I can do Hugging Face CLI download. I'm gonna say local dir current directory, and I'm going to say from Google Gemma, and I'm going to choose, so to be IT, I'm going to choose the file. So for example, config.json, right? This config.json file. So we just say config.json, and then we get the file here. So we can actually do this and preview the file in our terminal. For that, in case you don't know, I'm cutting the file, which prints the contents here. And after I do that, I pass it through JQ that gives us the formatted JSON, but I also could ask for property architectures, for example, right? Or I could go to, I don't know, maybe transformers version or some other thing, right? So hidden act, and then we get the result. So yeah, we can download one file, and as you can see, the file is there. It's not a symlink. And to do a symlink, I could actually do here local there, use symlinks. And when I download, well, let's delete that file. I have to put here true. Right? Yeah, right. So now this is a symlink. So if I show the original, it brings me back to the folder I showed before with the cache, and that is symlinked. If I don't do that, if I don't want to use a symlink, I can simply download the file, which I need to probably remove, and get the actual file. Okay, so that's for downloading one file. If we want to download the entire repo, we just leave it empty like this. It will start downloading the files to this folder. And for the ones that are really big, probably the ones that have this LFS icon here, because it's large file storage, git LFS, these ones are going to be symlinked because you don't want to re-download these things every time from there. So tokenizer.json, LFS as well. Yeah, so the ones that are symlinked are really large, and we could have symlinked everything by specifying that use symlinks option and leaving this out. So we're going to remove these things, do this, and this is really nice now because it's just symlinking from the cache of Hugging Face on my machine, because they're already downloaded. So it's really clever because it doesn't have to wait. If you had to wait, you would see something similar to this. We're going to remove this thing, I'm going to remove this stuff, and I'm going to press here. So this might slow down now my network. It's basically downloading these big files from another repository, and as you get them completed, they're actually completed in the cache, and then they're symlinked here. So we're not going to do that right now. I'm going to delete this test folder because we've already seen how to do that. And we're going to go to the cache of Hugging Face, and we're going to see what files we have here. These things are probably things that didn't get downloaded completely. And we have some files here for what didn't get completely downloaded before when I tried. So I have 17 gigs for Gemma 7B, 51 for the other, so this is probably not finished, and this is 2V for what I started downloading. So these things right now I'm not gonna touch because we might want to download stuff and I don't want to delete the cache, but these are the other models that we've previously downloaded on the live stream. All right, so we've seen a brief intro to what Gemma is. I mean, just really high level. We've seen that in Hugging Face, we can install the CLI really easily. And we've seen how to actually log in with a token, how to go to a repo and put the download command together so we can download one file or multiple files, either locally or sim linking. And remember that you will always be sim linking the files that are really big. All right, so let's go back here. Boom, boom. All right, so now talking about Gemma 2B and 7B, these models seem to be state of the art, like really performant. And what we're gonna do, we're going to go back to Hugging Face and we're gonna go to the model card and we're gonna try to see if we can learn how to use it. So let's take a look at how to use Gemma locally on our machine. And here we have the 2B and the 7B instruct models. Gemma is a family of lightweight, state-of-the-art open models built from the same research and technology. Let me actually pull this here. So built from the same Gemma models are well suited for a variety of text generation tasks, including question answering, summarization, and reasoning. This relatively small size makes it possible to deploy them in environments with limited resources, such as a laptop, a desktop, or your own cloud infrastructure, democratizing access to state-of-the-art AI models and helping foster innovation for everyone. This, in some way, is what Stability AI and other companies like Meta with Llama are doing. So one thing is we can actually, so we need to install transformers. Let me see, before we share some code snippets on how to get quickly started with running the model. First, make sure pip install u transformers, then copy the snippet from the section that is relevant for your use case. Great, so what they're showing us, let me make this really big so it's only one piece of text here. We need to do this on our environment. So what is the U flag? Let's look at OpenAI. What's the -u flag in pip install? And yes, I go to ChatGPT for many of these things nowadays. Upgrade. Okay, it upgrades if it exists. So it's the same as upgrade. Yes, is shorthand for upgrade. Okay, so we've learned or refreshed something for mine today. So let me see Conda env list. So let's list my Conda environments. Imagine, printer. Okay, so let's create a new environment. Let's create a new environment so we can run Gemma or like the code, the Python code that they have on Hugging Face. So this is going to be Conda create. The name is going to be Gemma. We're going to say that it's going to be Python 3. I don't really know what the best support is right now, and I'm going to say yes. So we're going to install that. We're going to let it resolve and create our environment now. And this should be done already. All right, so Conda activate Gemma, and we're gonna do what they told us to do, which is install, upgrade, or -u transformers. All right, so that transformers model package. So we're going to say that yes, that we want to do that, and then we're gonna copy the snippets that we want to use here. So running the model on a CPU. All right, so I'm gonna assume, so the transformers package by transformers. this is from Hugging Face. So if we have this library, I guess that it will know already how to get these models from Hugging Face. We have the model card. I'm not sure how it's going to work for logging in to get this access to this model. The thing is that because we already have this model on the cache, it might just be really fast and know that the model is already there and make use of the model however it wants to do it. So we're gonna say here, okay, so let's actually just create a folder there. So here, okay, so Python. Okay. So let me change this to Gemma samples, because we've seen that if we have generic names, we might make problems with like package name collisions and things like that. Okay, so let's take a look here. Touch. We're gonna create first run cpu.py. Great. So we are going to write the code here, and I'm gonna write it without copying, just so we might learn a bit of something. So we don't just. Let me actually see if I can. If Hugging Face has a dark mode. Okay, one sec there. Theme. Okay, dark theme. Great. Great. All right. That works much better with the prompter, so it doesn't really fade the colors on the display. Okay, and I'm gonna do something here with the chat. I'm gonna put it back to its place. Yep, and feel free to say something on the chat if you're connecting. Okay, so we got this, and we got this here. All right, so pip install accelerate. Why? Running the model on a CPU. Okay, let's see how to run Google Gemma on the CPU right now. So we're going to import from transformers, import auto tokenizer, auto model for causal LM. Now the tokenizer is gonna be auto tokenizer dot from pre-train, and then we're gonna do here Google Gemma to be IT, which is the one that we downloaded. The model is gonna be boom from pre-train Google Gemma to be IT. So that should be the same, right? All right, the input text is gonna be in the example they say write me a poem about machine learning, but I'm gonna say list 10 touristy plans. So 10 plans for tourists in Malaga, Spain. Boom. Input IDs. So we'll do tokenizer, input text, return tensors, PT, and the outputs model generate input IDs, print tokenizer dot decode outputs. All right, does this work? Let's take a look. All right, we can actually run it directly here. So we are in the Gemma environment, and we just have to do run ZPU. Oh, okay. Conda deactivate. It says we might have to restart. Job failed. Okay, let's take a look at what's the issue here. None of PyTorch TensorFlow flags have been found. Models won't be available and only tokenizers. Configuration, file, and data. Okay, let's actually take a look at the model. Doesn't have any requirements here. Does it have any requirements in their website? On their site? All right, let's just try. Conda activate Gemma. And then we'll do pip install PyTorch. Is it PyTorch or just Torch, I guess? All right, so what's going on now is we're installing PyTorch, and maybe that makes it work. Let's try again. All right, so now something else is happening there, and did you move from pre-trained to pre-trained? All right, human error. There you go. One more time, and downloading shards, loading checkpoints. So it seems visit the Picasso Museum. All right, you got it right. And the tokens are super short. Why is it outputting so few? All right, let's now take a look at the. This is 2B. I mean, we could be loading 7B as well. Let's look at the example. So I'm gonna go here. I guess this is more a matter of transformers. Gemma config. Okay. Okay, so there is some config here, and what I want to know is like how to add the tokens here. Okay, so make. So let's do here make the output have more tokens. Max length parameter. Let's see how we do that. I mean, max length. All right, so model.generate model. So I guess like model.generate transformers. So it seems like these arguments will be additional model specific arguments will be forwarded to the forward function of the model. The model is an encoder decoder, blah, blah, blah. Okay, so we need to take a look at the Gemma config. So maybe max length. Okay, yeah, so here they say tokenized a batch encode. Right, let's just try that. Max length 112. I'm sure what's going on now. Oh, all right. List 10 plans for tourists in Malaga. Visit the Picasso Museum, take a walk along the Paseo Marítimo, visit the Cathedral of Malaga, explore the Alcazaba, go on a day trip to Ronda, visit the Museum of Malaga, take a cooking class, visit the Botanical Garden, go on a hike in the Sierra Nevada mountains, visit the Aquarium of Malaga. I don't really know about the aquarium, but these are just a few ideas for things to do in Malaga. There are many other things to see and do in this beautiful city. This is pretty awesome, guys. This is working pretty well, and that was with the 2 billion parameter. Let's actually change this to the 7 billion parameters, and let's run exactly the same code here. Conda activate Gemma, and we're going to simply run that. It will try to download things because it's the first time, so downloading shards, but everything's there. So it's loading the checkpoint. This is okay. I deactivated my video because I saw there was some rendering lag, and that's because my computer's probably RAM was loading the model, and I guess what we need to learn how to do is how to load the model and keep it in memory so we don't have to reload it every time we run the script. The model is a lot slower, as you can see here, and yeah, so the model is a lot slower, but we'll get the output soon, I guess. And we can take a look the at the unified memory on my M3 Max in order to see what it's doing. This is actually CPU, so that's why it says rendering lag, not encoding lag. This is all running on the CPU. So I guess what we saw with the Llama C++ might be running on the GPU as well, more efficiently. I'm not really sure. It's taking really long time, a really long time. Okay. Let's see. Well, this was really impressive. I mean, I think this is great because this is gonna start to allow to use these models for free in code. I mean, in Python scripts and other things that we can do. I mean, I'm just thinking that for my marker stuff, the things that I do with Whisper, I could already use this thing to synthesize or like propose a title for a given like summary of content, or like grouping, creating a marker text for these things. All right, this is taking too long. Not sure why. Let's actually take a look at the memory. So this was the activity monitor. We're gonna go to, actually let me also pause syncing on YouTube Dropbox, because that probably GPU. Is that working? Seems like some GPUs, some CPUs are working. Okay, nice. Great, we got some stuff. Let's actually remove this. All right, let me remove these things and we'll take a look in a second. Okay, nice. All right, so these actually 10 plans for tourists in Malaga, Spain. History and culture. Explore the Moorish architecture of the Alcázar of Malaga and the Cathedral of the Santa Maria. Visit the Roman Theatre and the Gibraltar Museum. Immerse yourself in the vibrant flamenco culture with a show. Beach and sun. Relax. A day trip to Ronda. Explore the orange blossom. Foodie adventure. Shopping, nightlife. Nice. Relax and enjoy. Yeah, I don't really know why this took so long, but definitely a lot more detail. Can we solve coding questions with this? Like, can we maybe like leave this at whatever it is and ask a different question? Write a TypeScript React component with an OK button. Let's try that with 2 billion. That is pretty fast, and I'm not sure if like 3 billion is going to be really the 7 billion is going to be really slow. All right, so here's the graph. Okay, so that, I mean, that was super fast. So I'm going to put this thing here. How can I? Okay, yeah, so these are this is the CPU, the cores, and that was generating, but I put so few tokens that couldn't really write anything. So let's try again with more tokens. Loading checkpoints, there's no rendering lag, so this computer can handle it pretty easily. And now let's see what happens. It also takes some time, right? But it might be like 10 or 20 seconds to answer, let's say. It seems like these bits here, this peak that you can see, is that model that is using. So let's see when the output comes, let's see if these things here actually continue being there and or disappear, right? If that's the model using some piece of our CPU. This is taking longer because it's probably generating a lot more tokens. I mean, I don't really know what the default token size is, but definitely it's not 200, it's not 500. All right, so here's our component. Our application, handle click, on click, okay, handle okay, click. We import a use state hook from React, blah, blah, and it explains how to do all these things. Okay, that sounds good. And what I'm gonna do now is I'm gonna ask maybe with like 64 tokens, so it's not too much. You can see these pieces here, these mounts here are the pieces that are consumed by running that. So it seems like this model makes use of the CPU, but in a good way, so it actually doesn't overload the computer. Now what we're gonna see with the 7B is that my camera probably would like lag a bit, so I'm gonna leave it. Maybe we miss some frames, and let's see those mounts. Let's see how those are and whether there is some GPU use as well. I'm gonna leave this here. All right, let's run that. There you go. On first instance, when the model is being loaded, we lose some frames. So we lost 50 frames due to rendering lag and 19 due to encoding lag. There is no stress on the GPU because this is an example code for running this on the CPU. And as you can see, there's some stuff there going on with like the CPU performance cores, and then we generate. And this is a thing that is being generated that we seem like we need to actually add more. I'm gonna remove myself just to, oh, I can't remove myself from here, but from here. Well, maybe, yeah. So I remove myself because there's gonna be some encoding lag, so that you don't see me blocked or something, and that's it. So we seem to be okay. So this generated. It's close this stuff. There's no. Oh, it's generating still. Okay. So yeah, it seems like the CPU also suffers, but it seems like it's more used with like the 2 billion parameters. I don't fully understand what's going on. Why the other one takes more tokens? Mm, no more tokens, more like more work on the CPUs. All right. So while this is being generated, maybe let's clean up these things a bit. And let's keep going here with the examples. Great. So here we have Gemma Interactive. Okay, so let's make this big. We have only one column. This is the example we tried. We just added the max length here. Still thinking. Running the model on a single GPU or multi-GPU. We need pip install accelerate. Let's see, pip install accelerate. Is that also Hugging Face? Run your raw Python training script on any kind of device. Okay, does this work? Okay, all right, here it is. Import, so it's working slowly. You can see here on these columns. Great. I mean, this works pretty well for being 7 billion. Okay, I'm not gonna read this right now. I'm just gonna hope that we get support for free with like this, accelerate, and we're gonna look at our example. Device map auto. Okay, for this, we do need our panels here just to see if there's any difference on how this is run. So device map auto. Okay, so that is device map auto. Doesn't seem like we need to do anything else differently. So yeah, let's just try running that there as well. So it seems that this was properly installed, right? Yes. Great. So let's just try to do this again. Great. And now we're gonna do the same as before, just Python run that. Okay, who's gonna work now? Do we lose anything on the CPU? I'm gonna move here. I'm losing some frames, missing frames, more frames. We lost 68 frames. Okay, let's take a look at what's going on here. Placeholder storage has not been allocated on my program. Blah, blah. All right, so we're trying to see if we can directly run Gemma on a MacBook Pro's Apple Silicon GPU. So oh wait, tokenizer to CUDA. List available device list devices available to PyTorch. List devices available to PyTorch. Yeah, so all right, so let's take a look. So we're seeing how to use so PyTorch, blah blah blah, building from source, verify, NPS. Okay, let's actually just create a file. So torch touch torch devices.py, and yeah, actually the convention here is more underscores, so we can also rename that one to that, right? And now we close this. All right, so import torch backends nps is available. PS device equals, so let me put this here. All right, so I'm basically just following this example. So torch device nps x torch one device nps device print x else print nps device not found. All right, let's see what this thing does for us. Python torch devices tensor 1 device nps 0. Great, we do have it. So we've seen that this code sample gives us the answer to whether we have the MacBook Pro device on PyTorch here. So yeah, machine learning has advanced a lot, and now we have native support without doing anything. So what I want to do here is see if we actually were to put here generate. Let's take a look at where the code example was. Should show. Okay, so that's great. And let's close things. Great. So here, tokenizer to QDAP. Okay, so device map auto and the tokenizer run tensors to MPS. Let's try that and don't be ambitious. And let's put this here. PyTorch run CPU. And now the only thing we need is not to get any errors. I don't really know what's gonna happen. Maybe we do get errors, but let's see. It seems like it's working. I'm not losing any frames here. Dropped frames due to network. There's been some lag there, which I don't know. Oh, nice. So take a look now. So this spike here, this is really nice because this means that the model is actually making use of the GPU and it's not overloading my CPU at all, which is pretty cool, I would say. And now there's like some spikes on the CPU, but a lot less than before. So yeah, that's super nice. We're gonna continue seeing this graph, and I'm gonna leave it in here. So maybe we can put this like this, and I can go here. All right, so we got this message here. Things to do in Malaga. No, things to eat in Napoli, Italy. Great, so we're gonna put here maybe less tokens is faster. Great, so that let's actually wait. Let's actually count down. I have a timer here, so we're going to count down. This is gonna be flipped. It's gonna be flipped. Right, I'll do it and I'll let you know because this is flipped and we're gonna see it the other way around. All right, so I'm gonna do it now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, 16 seconds. And we've got an output in Markdown, so I can actually open IA Writer with an empty file here, and I can type this, and this is actually ready for print. It's Markdown text, and we can see it in different formats, but in the end, the important thing is that it's valid Markdown and it's been generated by the 2 billion parameter one. So let's actually go for the 7 billion parameter. Let's see how it performs here and whether this is something that we could use. Okay, so now I'm going to say here so my prompt was things to eat in Napoli, Italy. All right, so that's the prompt. And let's see. So the prompt is things to eat in Napoli, Italy. And that's the answer for 2 billion. Wow. What? And this is the answer for 7 billion. Oh, it didn't have space to do more. All right, let's let it talk. And let's see how long this one takes. So 1, 2, 3, 4, 5. Do we have any lag? It seems like we're still missing some frames here. Yes, 28 frames we lost. I don't know if that's a lot or not, but yeah, we're making use here of the GPU a lot more than before, and a lot more than um, a lot more than so a lot less on the CPU, right? So I guess, how are we gonna call this video? I think this video should be called something like Google Gemma LLM on Apple Silicon Max. Let's take a look there. Well, now you can see, this seems like there's some lag because of the model rendering, the model inferencing. All right, so this is up to 1 minute and 23 seconds. We have 512 tokens, and we keep losing frames here and there. So it seems like there is some load on the CPU as well. And the GPU, there's like spikes. Right. I don't know what I'm doing. Okay. So let's see this through, and then we can, yeah, there's like a lot of lag. Okay, I'm gonna hide myself. You don't see me overloading there. Yeah, so what's going on, actually, we're losing a lot of frames because the computer is like trying to generate tokens, and it's actually doing an inference in my machine. So it's not super performant. And I have 3 screens, and yeah, a lot of frames lost. But the good news is that the 2 billion parameters is something you can use locally and without any problem. We're at 2 minutes 50 seconds. All right, so this is a good generation. Let's see how it goes. Keeps going. How many tokens? 512. Yeah, 512 for the 7 billion parameter model seems like a lot. You can see it on the GPU. Let's take a look. What other modalities we have here? So running the model on a GPU using different precisions. So you can, yeah, okay. So this one, so float 16. This, if we get other precisions, we might make the model a bit faster. All right, and we're at 3 minutes 50. So not sure if this, yeah, so this just generated, just finished generating. All right, so let's actually get this. Great, so let's put this on the same document under Gemma 7 billion. So I don't really know, maybe it's there, but this is like this was like 512 max length equals that, 3 minutes 50 seconds. 350 minutes. Okay. Yeah, I don't really know what the best way to do this. Man, okay. And I'm not sure about the other one, but this is what we got. Naples is a vibrant city steeped in history, blah, blah, blah. Pizza, spaghetti, pizza napolitana, gelato, tartarella. Tips to experience the best Napolitana. Refrigerated dishes. Enjoy the relaxed atmosphere. Wow, okay. There is a difference. This was what we got. Pretty different suggestions. Anyhow, this was a great experiment. You've seen we've been able to run Gemma on the GPU and also on the CPU and how those differ. We lose frames on this, even in this expensive, powerful M50 Max MacBook Pro. We lose frames because, you know, they're bloating our CPU and GPU, and things get frozen there. But it's been pretty cool to be able to do this so quickly and so easily. All right, so one thing, let's now do some housekeeping for like committing the files. Make sure that if you watch this later, you can access the files. And I'm gonna write up some of the commands as well, so we can share them later as well with other people. So what we've done today as a recap, we actually downloaded Homebrew or like Hugging Face with install Hugging Face CLI. Then we actually did all this stuff, and then blah 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 from Hugging Face, and then we actually create an Anaconda environment. We did this with create and Gemma Python 3.11, yes. And then we did conda activate Gemma. We did install both which one was it? Transformers, Torch, and Accelerate. That's what we did. We did conda deactivate and then conda activate Gemma to make sure that we could do that. And then we ran CPU and then Python torch devices.py. Actually, I'm gonna put here run GPU.py as well, because what I'm gonna do is get this back at how it was for GPU, and we're gonna duplicate this file so we can copy paste. All right, so we can actually name this run GPU. And how we're gonna do that? GPU is this example with this piece. CPU is exactly the same without this stuff. So we can do here touristy plan, places to visit in Malaga, Spain. We'll leave it at that. All right. And then we have these things. So I'm going to go to my repo where I share all these things. We're going to make this there, and this one, there's going to be Gemma, Google Gemma. Right. And actually, I'm going to change this to this syntax. Okay, so now just put this in here. So we're going to move the files from this folder in the Gemma samples into the other one. Boom. And all we have to do now is to commit those files. You're gonna see here, we get those code diffs, and we just do add Google Gemma code samples. The files, sync the changes. All right, and now you are going, or you should be able to go to github.com/nonoesp/live, and you should be able to see this folder. So Google Gemma, and we have these beautiful code samples here. Maybe what we're gonna do is, let me look for the history pages. Okay, so we're gonna actually add the references to the code for when we got them from. And then this one. Put this here. Okay, one more comment just to add code source URLs. Great, and now we do have these things here, and you can refer back to where we got those from. So this one and these other two also have their references. Great. Okay, so that was some housekeeping for pushing to Git. Want to make sure before we go that I've shared everything. So we have all these things and how to do this. Maybe now we can record some tutorials. So we have here, it's just the models symlinked, which we don't really need for anything. Even though I can store this with my projects. Let's hack it. There. All right, so now we have that folder stored properly. All right, I would really appreciate if you are connecting offline, if you let us know how you found us and where you're connecting from, and I'll remind you that you can subscribe and click on the bell if you want to get notified when I go live next or when I upload new videos. And please go and hit that like button if you're enjoying the content and you'd like to see more videos created by me. Nono Martínez Alonso. I host this stream on creative AI and coding, and also the Getting Simple podcast. All right, so one thing, let me just take a look at some stuff here. Right. Okay. Following the Blue Fox daily loss. All right, that's not intended there. And I just want to take a look at some stuff. Okay, and what we're gonna do now, I'm gonna take a quick break, and I might actually record some of the things that we've done, record them again, and take a, yeah, like in case we can do that now to produce some. Yeah, I might not do that right now, but it would be good to create some video tutorials of the things that we saw. All right. Let's actually wrap this up by um, creating an actual, this is what I was looking at, an actual cover for the video. So we had these LLMs, AppleX, Apple Silicon, Gemma, Apple Silicon, Google, Gemma, Apple Silicon. All right, let's take a look at what we're gonna do here. We're gonna go, let's create the thumbnail for this video. I mean, if you don't want to stick around now, it's fine. But for those of you want to take a look at my process, I'm going to be doing that live before we go, and then we'll create the chapters. So Gemma, LLM, Apple Silicon, that's too much, right? Apple Silicon. Yeah, Gemma, Apple Silicon. Let's see. Yeah, I mean that could be the cover, and then we'll see what we do for the and maybe I can put something here. 2 billion. Right. Okay, let's see if we can get that image from there. Oh, SVG. That's nice. Great. That's better than I could expect. And this font is Google Sans. Let's see if they have it on Google. on Adobe fonts. What? That's definitely not it. So Google Sans is not open. Arc. Okay, I guess we can simply tweak it here. All of that for a thumbnail. Okay. Right. I mean, putting the logo there and maybe even the Hugging Face logo. And I'm gonna use this automatic filter to see if we can get Photoshop to generate an empty background for more contrast. Okay, so that's gonna be this, and then the title would be something like Gemma AI on Apple Silicon with Hugging face. See, maybe that's it. And we got it. So this is perfect for putting this on top. Great. And maybe I do put this like this. There you go. Okay, so this would be our thumbnail, and we're gonna save that here. So we're gonna do live 113, and I'm gonna close this stuff. All right, that I'm going to, okay, so let's add some links. So we have here that thumbnail, and we want to add some links and chapters. So now we're gonna add the links and the chapters. I put one on the chat before. Hugging face in homebrew. Basically, brew sh Hugging face CLI. Put here. I'm gonna put Hugging face Gemma 2 model card. Let's put this. Google Gemma 2 billion the instruct and 7 billion instruct. And we've also seen Hugging face, so transformers, Hugging face transformers. And do you think it just accelerate? Seems like it. Let's see. Yeah. Okay, so that's gonna be it, I think. For this one, I think we'll put the title if this fits. Seems pretty long. Google Gemma AI. What's the best title here? All right, save. Let's see if that saves. Wow, we're live still. And now, what I'm gonna show, these are the chapters. So if we go to recordings, OBS, open this markers file, as always, what we can do now, even while we're live, we can once again go to my scripts and do, let's see, all let's see. Okay, so marker, add, and transcribe all. So when we run this, I don't know if we'll drop any frames, maybe we do. What will happen is that this thing here is going to start to get populated with the transcript, the text that I was saying at each of those moments. And that means that we're going to be able to know exactly some of the things that we were talking about. For example, this is Elgato Prompter, right? Blah, blah, blah. And okay, I'm going to be talking about Google Gemma. It's Nono here, and this is a hands-on overview on Google Gemma. So things like this, I mean, we have many chapters in the stream, and this is a script where I'm using an open AI model. Like, it's from OpenAI, but I also mean like an open model from OpenAI, which is called Whisper. And we can do this on my machine live, streaming, recording, and rendering and encoding, and we don't lose any frames. It's pretty performant with the network that we're using. I think the default network here is let me see which network it is. Small n. Yeah, it's small n. It's not the tiny one, but it's the small n. Right? So we've used the title. And now these are my markers, and we're gonna add that to the video as soon as this finishes generating. All right. Yeah, that's it for today. I'll edit these things on my own and add to the video timestamps. So if you're watching this offline, these are gonna be already posted there. We're just waiting for the last one right here. It's gonna pop up. All right, what I'm gonna show, these are the chapters, blah, blah, blah. And that's what we're doing right now. So yeah, this was a stream for today. And that's it. Do I record anything? Maybe now that we're here, I can do that. But let's first clean up these things. So Elgato Prompter, and this one, Elgato Prompter. I don't really know why there are two, but marker, remove all this stuff. Okay, previously, so this may be today. I also remind you, introduction, this is a bit before, so maybe it's not there, and then we'll put the start one. Okay, I'm not going to talk. This is Interlude, Google Gemma. Right. Let's install. I need to look at this one. Okay, and I'll do this offline. We're not gonna do any other stuff remote right now. So let's go here and take a look. Yeah, so That was it for today. I will remind you that you can join the Discord community at nodoma/discord. And don't forget to subscribe and click on the bell if you're gonna get notified when I go live next or when I upload new videos. Honestly, I want to thank you for watching, and I'll see you next time. Thanks a lot. I'm Nono Martínez Alonso, host of this stream and also the Getting Simple podcast. Bye.